Let's talk about how to name a Newman projection. So, in essence, given a Newman projection, a IUPAC name, right? From my previous video, you would have seen that your front carbon is right here. The big circle represents the back carbon. So, the first thing you need to draw is the front carbon bonded to the back carbon because that is true. The front carbon is bonded to the back carbon, which is the big circle. Then you take your time and you start putting the things that are bonded to the front carbon on the front carbon. So here we go. On my front carbon, I have a CH3. So I'm going to put the CH3 on here, right? I have a hydrogen and I have a CH2, CH3. Now I like to keep the group of the three that has the most carbons in this direction. It makes it easier to name. So I'm going to bond it here, CH2, CH3. And if you look at it, you'll see that the front carbon is bonded to the CH2. The CH2 is what's bonded to the CH3. Then the only thing left is your hydrogen. So you put your hydrogen on here. Let's now go to your back carbon. Your back carbon has a hydrogen, a CH3, and a CH2, CH3. CH2, CH2, CH3. So let's bond those, right? Like I said, I like to keep the group with the more carbons in this direction. It makes it easier to name. So I'm going to write CH2, CH2, CH3. So we've taken care of this and we're left with hydrogen and CH3. Remember, it's what's unbonded, what's drawn on the circle, right? That circle represents the back carbon. So this is what's drawn on it. This is what's on it. This is what's on the back carbon. So here's the back carbon. I already took care of CH2, CH3. I still have a hydrogen and a CH3. So let's put in my hydrogen. Let's put my CH3. Now you need to find, so we've converted it into a format. This is a partial condensed structure that we can now name, right? So to your longest chain of carbons, and if you don't remember, I already taught you how to do this. Your longest chain of carbons is running straight across here. It's 1, 2, 3, 4, 5, 6, 7, right? And we're going to number in the direction that gives us the substituent we encounter first, the lower number. So let's number 1, 2, 3, 4, 5, 6, 7. I could not have numbered from this direction because if I did that, it would be 1, 2, 3, 4. My substituent encounter first would be on carbon number 4, so we don't number in this direction. That's if you have forgotten how to number. So now I have this substituent and this substituent bonded to the carbon of my longest chain. So to name this, right, your parent name comes from the 7 carbons. So that's heptane, right? Then I have 2 substituents. They're both methyl groups. One is on carbon number 3 and the other one is on carbon 4. So you write 3, 4. That tells me that one is on 3, one is on 4. Then because it's two of them, two groups that are the same, to show how many times they repeat, you write di because the methyl groups repeat twice. There's one here, there's one here. So di tells me I have two of them, dimethyl heptane. And that's how you name that. Let's do one more example. All right. So again, front carbon bonded to back carbon. That's the first thing you draw. So your front carbon is always bonded to the back carbon in your Newman projection. All right. My front carbon has a CH3, a CH2, CH3, and a CH3, open parentheses 2. Let us take care of these first, then we talk about this. So I'm going to put my CH3 here, right? That's this CH3, and I'm going to write CH2, CH3. Then let's talk about what this means. This is my front carbon, right? I'm going to put it in red. This is my front carbon. Bonded to my front carbon is this carbon. I'm going to put an asterisk at this carbon. So let's put this carbon on here and give it its red asterisk. Now bonded to the carbon with the red asterisk is a hydrogen and two CH3s. This open parentheses tell me I have two CH3s and they're on this carbon. I mean, there's nowhere else they could go. Here, this carbon has the hydrogen and the two CH3s. The open parentheses tell you it's two of them, and the fact that this carbon comes before it, it means it's on this carbon. So let's put the two CH3s in. So we have CH3, CH3, and don't forget there is a hydrogen. So let's put the hydrogen in as well. Let's go to the back carbon. My back carbon is the big circle. You have a hydrogen bonded to it, another hydrogen bonded to it. Here's the here's the circle, right, which is the back carbon. As you can see, this is bonded to the circle, this is bonded to the circle, this is bonded to the circle. So we have two hydrogens and a CH3. Let's put that onto our back carbon. Hydrogen, hydrogen, CH3. Now, we need to find our longest chain of carbon, right? Let's go straight across and see if that's it. 1, 2, 3, 4, 5. Okay. What if we go 1, 2, 3, 4, 5? That's also a long chain, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, if we go in this direction, we have the long chains in this case is the same. If I go 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4, 5. That's one long chain. This long chain has three substituents, right? If we go straight across, we only have two. So our longest chain, when you have two long chains with the same number of carbons, you pick the one that has the more substituents. So my long chain here has 1, 2, 3 substituents, right? Okay, you see that. All right, cool. Let's go back, take that out. Let's do the other long chain. The other long chain that runs straight across only has two substituents, right? So we will not use the green. We will go back to red because green only has two substituents. If you have two long chains and a molecule that are of equal length, you pick the one with the more substituents. Okay, so green, when my longest chain runs straight across, we only have two substituents. When it's red, we have three. So let's go back to red. Or not, it's not taking me back to red. It's fine. Let's draw it. So let's draw our red. So 1, 2, 3, 4, 5. Okay, and these are our three substituents. One here, one here, one here. So we will number. And we number from this direction because if I had started one here, the substituent I encounter first would be on 1, 2, 3. If I number this way, substituent I encounter first is on 2. So let us name this molecule. So here we have, I have an ethyl group and I have a methyl group. Two of them actually, there's one here as well. So to name this, you're going to listen alphabetical order. So it's 3-ethyl. It's going to be 3-ethyl. Your methyl groups are on 2 and on 3. So it's going to be 2, 3, 3 dimethyl, and it's 5 carbons in your longest chain, pentane. So that's how you convert a Newman projection into a name. Just be careful when you have chains that are of the same length. In one molecule, just pick the one with the more substituents.